Check it out. We have an integral that is quite improper. Let's deal with this improperness. What's improper about it? We're going towards infinity. Well, you can't get there, but you can pretend to with a limit. So let's rewrite it as a limit. I generally let this one be a and that one be b. That's the way you'll see it in most textbooks and other explanations. So we're going to do the limit as b approaches infinity, because that's the culprit. And it's going to go from the natural log of 2, which is a number, to b of e to the negative x dx. Okay, we're ready to integrate at this point. So let's just find the integral of e to the negative x. The integral of e to the negative x is e to the negative x, with an exception. Because of u substitution that I'm not going to show, we have e to the negative x, but I need the derivative of this to be this, and the derivative of this would be, don't write this, would be that. So because of that negative sign, if I put a negative here, it changes that one. So this is it, from the natural log of 2 to b, don't forget your limit. Limit as b approaches infinity. Right? I did not forget my limit, I left space for it. See? All right, we are ready to plug in a b, plug in a natural log of 2, not a negative 2, and subtract the 2. So we're going to have the limit as b approaches infinity. And we're going to just continue to work this thing out. So we have negative e to the negative b minus negative e to the negative natural log of 2. Okay, there's a lot going on here. And I would like to point out the obvious. This is a b, this is a b. The limit only applies to this first term. I don't need to worry about the limit of the second term because it's not really an issue. So I'm going to just proceed with this. I have the limit as b approaches infinity of negative 1 over e to the b. I'm just rearranging some things. We're going to do it that way. I think it's going to make it a little bit easier. So this is the limit I'm dealing with. It looked like limit minus that. It's the limit of negative 1 over e to the b. Again, just taking this negative exponent, sending it to the denominator. And then we're going to add, and again, this limit does not apply to this term at all. We're going to have 1 over e to the natural log of 2. And we'll proceed with this. So let's evaluate a limit. If b approached infinity, we would have e to the infinity. That's large. So 1 over infinity, theoretically, would be basically 0. So this is 0. This goes back to a lesson called limits at infinity. And so basically the denominator overpowers the numerator. It becomes 0. And in this case, e and ln, in this configuration, they cancel out. Big long list of reasons why. And I would have 1/2. So e and ln, they're just gone. It's just in 1/2. So final answer is 1/2.